Okay, thank you very much for your audience here and being here, though it's Friday afternoon. Yeah, what I'm talking about is a little bit different than the other speeches in the morning, because I will talk about how you can create an innovation culture, and I will also show some results out of this, and so that you get faster with your innovations. As it was announced, I'm with Siemens, and pretty much of you probably know from Siemens, okay, they build white goods like coffee machines, refrigerators. We build trains, we build healthcare products, and so on. Maybe you don't know that Siemens is also one of the hugest software houses in the world, with many, many thousands of software developers. And of course, this means we also have to think on new technologies, bringing them from IT to industry. And Siemens is changing itself again and again, and faster and faster. And why? Yeah, because everybody of us is going to the internet. Everybody of us is used that things change, and they change faster and faster, and we expect also speed. We expect things to be fast. We go from centralized power to decentralized power again, working with digital grids and all these things. So our life changes. People move to cities, and there they have then different requirements to their surrounding. In the morning, we heard about autonomous cars and vehicles and stuff like this. Also, the requirements for buildings will change with that. And we have a volatile environment, thinking on topics like Brexit or now the war, Turkey, and so on and so on. So this means we have to adapt ourselves, and we have to do it fast, and we have to go forward. And this is also true for Siemens, and therefore Siemens founded a new organizational unit, which it calls IoT. And IoT, as you can see, has a worldwide setup. And the task of IoT is not to develop products. Up to now, Siemens always develops products, but this unit will not develop products. It starts with consulting our customers how they can change their business, digitalize their business. Going on also how they can improve their efficiency. Also doing co-creation, co-development, implementing services and solutions, and also run those solutions. And we have to do these things, and at the same time also maybe sometimes jeopardize our own products, because we will support the worldwide trend from products to services. And why is this necessary? And why is it necessary to become faster and faster? Let's look back for a moment. In former times, if you think on who really did innovations or inventions, you had the universities, and you had big companies with research centers. Siemens also had some research centers, and one big center in Erlangen, also generating this superconducting magnets for MR systems and so on. But this means only some people were thinking on innovation. And this changes. Why? Many innovations today base on transferring them from the consumer market to industry. Probably some of you at least were in a tech lab and using 3D printing. 3D printing was there in the consumer market long before the industry was thinking on it, and recognized that with 3D printing they can have very small batch sizes in the production or customized products and so on. Probably you also know about that Google can predict influenza and stuff like this. So we use artificial intelligence without thinking really on it. We use digital twins. So if you build a new house or if you buy some expensive furniture for your house, probably you were shown some digital twins and how this could look like in your flat. So there are many things. The gamer market uses virtual reality. Yeah. And now we think on industry. In industry, cloud took a very long time until it was really used because of security reasons. And now it really starts. You know. When I look back in my own career, long time ago, when I did magnetic resonance imaging, we introduced remote service. And first time, the customers plugged out the Ethernet and said, okay, you will only have access if I have a problem. Meanwhile, or let's say since 10 years in the healthcare arena, this is no problem at all. All MR systems, CT systems, and so on, they're always online. And remote service is quite common. If there is a problem in the remote service center of Siemens, something flags up, they log in and they save the problem often even before the doctor experiences a problem. Let's think about 5G, maybe an upcoming technology which is now also very interesting. Typically we talk on our phone networks and stuff like this, but 5G could also have the potential to replace a lot of cables in our factories. And let's therefore think on how can we be faster to transfer technologies from the consumer markets to the industry. And there, this old strategy of having research centers or having dedicated innovation teams, it will not work out anymore. Because we need the ideas of all of our employees and people, or at least as much as possible. And this is why my strategy is to implement an innovation culture here. We need this idea culture so that everybody feels invited to contribute with ideas. And if he contributes an idea, then we have to be fast to evaluate. And of course, we are in a complex world. Complex means, okay, it's not always predictable if something will pay out. So we have to do experiments. And if an experiment fails, it does not mean it has been a bad idea. The guy should just come up with the next idea. What we do is we take an idea, we try to evaluate it as fast as possible in several steps. And if we think it really has the potential for a good business, then we will go forward with it until we really have a solution that we can sell. Now, how do we evaluate such an idea? As technicians, we often tend to say there is a new amazing technology and we have to use this. We have an implementation already, but it's old-fashioned. And we like then this argument, and if you use the new technology, then it will be better maintainable, stuff like this. But do we really think on our customer value? Do we really think in terms of our business? Is it in the focus of our business at all? And therefore we have to take into consideration things like, what is the strategy of your company? Where do you want to go to? Is this really the business you want to be in there? Or the other one, think in terms of your customers. Which problem of your customer will you solve, which is not yet solved? So innovation often is taking a technology, which was not used in your domain up to now, and solving a problem. Solving a problem of the customer. This is innovation. And the last thing is, of course, you have to look on technology trends. You have to look on to new ideas. And this is why I want to have this idea culture, or we implement this. Because if you just, some people do it, you will not be fast enough and you will not have enough ideas. You have to have enough ideas so that you can select the best of them. And there are many experiments which said, okay, you can have the best people and you can provide them a lot of incentive. They are finally not better than just normal teams who are just motivated, who just know they may do these experiments and there is no reason and no problem if they fail. And then they should just the next experiment. So we take these criteria from here and we generate a backlog. And then we have to select. And for this, we take an opportunities canvas. So we look under these things from different point of view, customer point of view. Of course, is it realizable? Of course, is the effort that we need and the money we have to spend to realize something, is it worthwhile to go for? And last but not least, of course, we also have to look into and what is the value for Siemens itself, finally. It has to be a win-win situation for our customers and for ourselves. So we do this backlog, and finally we set up an innovation team. And innovation team means it is an interdisciplinary, autonomous, agile team. If you go in these areas, if you do things like customer co-creation, this means the team will have to do decisions. The team will have to go for new things which were not there before. So it has to be interdisciplinary and it has to be autonomous. But still, this is not enough. At least for me, it is not enough. And there is a big potential in Siemens and a big potential in our new unit, IoT. And this is our worldwide setup with a lot of teams, a lot of people. You saw these 6,000 developers before. And what we are doing is also the following. We have this international team and there is a head of TI everywhere. And I collect them as a team. And thus we have a very, very strong backbone. For instance, in Slovakia, we have about 500 developers, and they are first of all concentrating on building technologies. And you might be surprised how intelligent a building might be. But another focus point and very, very important for us is healthcare. You saw the booth out there, and there will also be a talk on that. And healthcare is really high technology and very innovative. And now there is, of course, ideas like taking technologies which were used in one scenario and also using them in other scenarios. In healthcare today, you are also talking about a digital twin of your patient or of his heart and stuff like this. You use many, many different technologies to serve the doctors, the nurses, and so on and so on. So there are a lot of potential synergies that we have here. And one of the solutions I will show you in some minutes, we have shown in this team, and our Chinese guys have taken it up, used it to serve some customers, and even improved it. You know. And there was an inspiring talk yesterday so that we transferred back then these topics. Now, showing also two results of that. In industries, if you think on assembly lines, and if we are really honest with us, often enough we face situations which are not the same as what we often saw in the morning, very fancy technologies, autonomous cars and stuff like this. Often enough you see still industries and production lines which were maybe just got rid of the paper. But they are not really streamlined and not optimized at all. Yeah? So there is a lot of potential there. And if you want to start, you first have to get an insight what's going on there. And this is why we generate our solution production throughput inspector. And what he does is giving an insight. Now, if you want to get an insight to your production line, you first have to have some data. And today, there is no standard for it. And if you're in brownfield, then it's even more difficult because these machines might be there since 10 years or 20 years or something like this. Do you remember one of your software programs that you have implemented which are still running since 10 years? So you have to deal with a lot of technologies which are quite old and of course also with new technologies. So first of all, we take care that we can connect a lot of different data sources from old to new. Then, of course, we also need to have some IT, and we use cloud technology, but there are still many people who don't want to transfer their data to the cloud, so we can also do this on premise. But to be honest, there we do not invest ourselves too much. It does not really make sense to compete with Google and Amazon and so on. And Siemens also has a platform for that. So therefore, we as IoT, we just use what is there. Interesting is then again the upper layer, because there you're at your customer. And now remember what I said before, you have to solve a use case for him. And therefore, we look into these different roles in a factory, the planner, of course the manager, and often enough their interests are quite different, to be honest, foreman and production stuff and so on. And now we can generate different dashboards. One of it is this one here, which just shows the production line, and of course what you probably now already thought on is you directly see with the different colors where you have bottlenecks and where you have problems. So the manager could just log on and look onto his iPad and see, oh, I have a problem, or no, I can go on drinking my coffee here. You see your throughput, your current throughput. You see the throughput of the past hour, and thus you already have a very good overview. Of course, for some things you will need more insights, and I just show some examples because there are many dashboards that are available there. For instance, you have a heat map, or you have this first quartile versus median to see how is the variation. What I like a lot is this whisker plot, because what you see here is with these big bars, 50% of your production are within this deviation. And then you have also exceptional points. Now you can think on, okay, if you have one station and these are the different stations in your production line. And now if you have one station with such a high variation, it could be two things. It is not a problem if it is due to producing different products needing different times. But it could also be that you really have a big jitter. And then of course your production will not be reliable. Then you have to act. And the last example, in nearly every production you have buffers, and buffers shouldn't be too big, costs money. They should also not be too small, because then you might run into the problem not to be able to produce anymore. So you can define your limits where you want to be, and of course you see where your current state is, and therefore also you have some insight. So if we go to a customer, first of all, we should analyze to a certain extent what is his current state. If we know this, the next question could be, and how do we now avoid blockades, or how do we avoid inefficiencies? And yeah, we implemented another solution that we call advanced flow. In this demo here for this presentation, we took a small model of an assembly line that we built up in our laboratories. And yeah, it's quite small, it's quite easy, so it's easy enough to explain, but it's also very comparable to a lot of production lines. So many people who saw this said, oh, but this is quite similar to us. And what you see here is up there is a feeder. It just puts some small boxes on a conveyor. Then there is an inlay put into this, and there are two stations putting different plates on top of it with different colors. And the one puts blue and white, and the other puts, I think, white and red on it. And yeah, what did we do? We first of all took a Siemens product called Mind Connect. So we connected our assembly line to the cloud solution, industrial cloud solution of Siemens, which is MindSphere. There we implemented several applications. If you get some data, typically you first of all have to select those data that you really need. In most cases, you collect many more data than you really need. Then, of course, you want to learn from historical data, so you have to store them. And you have to have artificial intelligence to learn from the past. Finally, we implemented a controller, and we implemented an algorithm optimizing now the sequence and the timing of the products. You will see in a second what I mean with it. And yeah, for this example here, we also implemented a UI. In a real assembly line, you don't need the UI. And what happens now? On the left side, you see the non-optimized system. On the right side, the optimized system. Left side starts much faster, so seems to be faster. But you also see that on the left side, cups are cycling, because they are not at the right time in these stations where the plates are put on top. On the right side, since we have this algorithm there, none of the cups were cycling anymore. And yeah, to show it a little in more depth, what happened is the following. Left again the original, right the optimized side. We start faster, but on the right side, we start in another sequence, and the cups start in a point in time when following will happen. The system learns how long it takes to transfer certain products or pieces from one station to the next one. And knowing this, it can start the production of a certain product just in that point in time, so that the station itself sends out the piece before, and then the next product can directly go in there. So there are no waiting times anymore. There are no cycling times anymore. And we also can reduce buffers in an assembly line. There we had an experience on the other side. We applied this to a factory of Siemens in Berlin. And when we started to apply this, we were wondering, because it didn't work. And what we then recognized was the workers on the assembly line, they became nervous because they were used to having buffers. And now this algorithm reduced the buffers and reduced the buffers, and they got nervous and switched off the algorithm. So we had also to go there and explain to them what happens so that they didn't switch on anymore. We had also another experience. Our goal, of course, was flow optimization. But now economy changed a little bit, and they did not produce as many pieces as possible. So the algorithm did not really bring a benefit for them because they had not more to produce. Yeah. So on the other side, we saw they had problems. They had error messages. Error messages that they wanted to produce certain products, but their intralogistic hadn't provided in time the pieces to do this. And what we did then, we changed our algorithm. So we didn't change the architecture, we didn't change the surrounding implementation, and we didn't change the integration into this factory. We just changed our algorithm, and we could reduce this number of error messages by 40%. So, and this then again, of course, was very beneficial for them because it reduced costs a lot. Why I'm telling this story? You have to be flexible to a certain extent. And with interdisciplinary teams, you have the chance that you get different competencies into this team. And then you can, so that you can handle situations like this. You need somebody who really understands how assembly lines work. You have to talk to different roles, to the managers and to the guys being on the assembly line. And I can tell you the goals of both roles are quite often different. You know? Because the goals, the people on the assembly line itself, if you go there and you want to optimize such a thing, first thing they think on is, okay, what is my job in the future? They don't like it. So therefore, it is a lot of empathy that you have to take there and so on. And you have to take decisions online. Yeah, but you can see here we had an efficiency increase of 31%. And now think the following. How can you achieve such an improvement with other technologies? In former times, you would have to have a big invest because you need new machines. Now here, the invest is very small. You have to just implement a little bit software. You just implement a service, a data service, and then you can get these achievements. Big difference. Just two examples of IoT. Of course, there are a lot of solutions that are in place, that are under development. And this shows again this potential, what I said before, yeah, having this big team with all the different countries and so on, where we have different states in our industry and different customers. This gives us a big chance to transfer technologies, to transfer ideas from one place to the other one, and thus coming up with new solutions for our customers, which are often very beneficial as those which I have just shown. And we are in many different domains. I had told to you that we are in buildings also, and this first of all here in Slovakia. And one other example is in this arena we have implemented databases, knowledge-based databases, and we have also semantical interfaces implemented so that we can gather the data information of the different things in the buildings. And exactly this technology, this software technology, we are now transferring to the industry so that it is more or less plug and play, adding new items and connecting them to our systems. this was my last example and my last slide, just to animate you a little bit. And yeah, base for all of this is we need the ideas of all our people, yeah, because you experience at home, wherever, new technology, what it could bring, and you often enough have ideas, very good ideas, how this could be valuable also in a different domain, in industries, wherever. And this is why we implemented this idea culture and collecting all the data of all our people. Thank you very much.
All right, thank you. Helmut Ziegler, thank you very much. There are no questions on Slido, so I can't ask you any questions. And I'm not into this industry, so I'm not going to say anything smart. But people can talk to you because now we have the break with the discussions and the experts and the demos, and you have the Siemens stand right out the door. So if people do have questions, they can come to you. So ladies and gentlemen, before the break, give him a round of applause. Helmut Ziegler, thank you very much.